diameter, and the two endpoints are here. We can name it A, and this place that can be named what? B. Now all we want to do is to draw this, to move from this point as well as this point into somewhere else on the circumference of the circle in such a way that what? Both point A and B will what? Converge. So doing that might involve doing following this step. So this one we have to move like this, while this one will move like this. So we can see that the two meet at this point, which we might name point C. But at this point C, the angle there is all movement that involve moving from here down to this place. So and that is what we call the angle at what? Angle in a semicircle, because that's the angle which faces what? The diameter. So the value of the angle is 90 degrees. So what we have here, the meaning of this is what? P plus Q is equal to 90 degrees. And reason for that is what? Angles in a semicircle, is a right angle that is what? Is 90 degrees. Now we can see in these things, the result we have here is combination of both P and Q, but we are also what? To report P as well as Q in a separate manner. Now achieving that means we have to what? Keep applying the theorems. So with made mention of theorem 1, we've already used second theorem, so which means our last hope now is to what? To use the third theorem. So the third theorem is the one which talks about what? Angle in the same segment. So since that's what we are interested in, so what I would rather do is I will pick one of the angles given to me, so which is angle 65 here. So I want to verify where is the chord upon which this 65 degrees is resting. So to do that, I will go to the point where the angle 65 degrees is formed. So we can see this 65 degrees is formed on point B here, and two lines that comes together to form that angle is this line here as well as this line. So to now know the chord where this 65 degrees is resting, so then what we do is from this side here, I will keep moving until what? I hit the circumference of the circle, and as well as from this point I will also move until what? I'm able to what? End where? Until I stop at what? Another point on the what? On the circle. So which means the movement is going to be like this, from here down to this place. I can call this place C. Okay, let me call this place D. And as well move from this point down to this place, which is A and D. So, but the two has to be joined because AD is a chord, so that chord has to be shown. Since it's not shown, we are going to construct that. So that's situation whereby it might be necessary we do what? We engage in some construction activities while we're solving our question. So constructing may become joining the line like this. So we can join the 2 points together like that. So which shows angle 65 degree here is resting on chord D. Or we can say that angle 65 degree here has AD as its what? As its chord. Now applying angle in the same segment simply means we are looking for another angle which has this A and D as its what? As its base. So that is, we are looking for angle that is sharing the same chord with angle 65 degree. So to do that, we go back to that point A as well as point D. We want to move from here, elsewhere, to another angle in the circumference other than the one of 65 degree. So the movement can be from A down to C here, and the movement can also be from D down to this same C again. So we can see this is the point. This is the point, and we can see that two lines. Now at this point we are going to form a new angle. The angle formed is going to be distance from here to here, which is the same thing as here to here. That distance is what we termed as what? As P. So which means P shares the same chord as that of what? Angle 65 degree. As a result, we say that P here is equal to 65 degree. But remember, once P is known, then automatically we've gotten the value of Q indirectly. So what we will do in this situation is to say that what? Is to substitute the value of 65 degree into the expression which I have above, that is 65 degree plus Q is equal to what? 90 degree. So Q in this wise is going to be obtained by collecting the like terms. That is, Q here is going to be 90 degree minus 65 degree and we can see that Q is going to give the value of what? Of 25 degrees. So that one also completes the solution to the fourth question, that is question number 4. So we shall move ahead. So we'll move over to the next question now, which is question 5. Now in number 5, so I have this diagram. This is R, 53 degrees, and this is S, center O. That's the 5th question. Now in number 5, we are as well as to find the value of R and S. So to find R and S here simply means we have to apply, to think of which of the 3 theorems is going to what? Be applicable in order to arrive at the value of R and X. So we can begin with the first theorem, the one which we denoted as our first theorem, that is the one which talks about the relationship between angle at the center as well as the angle at the circumference. So we can see in this case that no angle is formed at the center. So we don't have any angle given at the center at all. So it shows that first theorem is not going to be useful. And the next thing we can do is to think of the one which talks about angle in a semicircle. And we know quite alright that to talk about angle in a semicircle, there has to be a center and the diameter is drawn to pass through such a center. So such exists in this case. So since such exists, then the next thing is to identify the 2 endpoints of our diameter. I can call this place P, I can call this place Q. So this diameter we have in this case has 2 endpoints named P as well as Q. Then the next thing is what? To join the 2 somewhere else on the circumference of the circle. So redrawing it means P will move this way and Q will move this way. So the 2 will meet at points, let's say point R. So the angle formed at that point R is what? The angle in a semicircle. So that simply shows that what? The angle here, right? That is what the R is describing there. The value of all angles there, at times it may be an angle, it might be 2 angles, it might be more than 2 angles. So combination of all the angle here, that is movement from here down to here, is what? 90 degrees. So and that is what we call what? Angle in a semicircle. So then you can say that R plus 53 degrees here is equal to what? 90 degrees. So reason for this is what? Sum of angle in a semicircle is 90 degrees. So to get in R here means we have to collect the like term by saying that R here is 90 degrees minus 53 degrees. So when we subtract them, so the result that gives is going to be 37 degrees. So R in this case is what? 37 degrees. So the value of R button can now be positioned here so as to be able to determine the value of the last letter, which is X. And we can see when we go through this same variable, so we can observe here automatically that application of angle in the same segment is not going to work. Since that is not going to work, then to getting the value of Sm means I have to think beyond the application of circle theorem. So then the next thing I can make use of in order to solve this thing is either that of triangle or that of angles between lines. So since the diagram we have here comprises of what? Triangle. So we can see the S we have here is in a particular triangle, is an angle of the triangle, then it shows that what? The property of triangle we are going to use. And since the triangle we have in this case is not isosceles nor equilateral triangle, if this thing were to be an isosceles triangle, two of the sides will be marked by a symbol which shows that what? Those 2 sides are equal. And likewise in the case of equilateral triangle, the 3 of the side is going to be marked by the same symbol. Since none of the side is marked, what this simply means is that what? This is a case of scaling triangle, and to apply scaling triangle simply means 2 angles has to be known. So once 2 angles is not known, we cannot apply the concept of what? Of the scaling triangle. So to doing that, let us verify the diagram again. Now, one thing is missing in this question. There is this symbol as well in the question. Yes. Now, we can see this angle is given as 37. Automatically, this angle as well is given as 90 degrees. The reason is this: the distance between this place and this place, this is a line, and it is divided into two angles. This is one angle, this is the other angle. So when we combine these two angles, the value it gives is 180 degrees. But this place is 90, so it automatically shows this place is 90. So to solve it now is to say that S plus 37 degrees plus 90 degrees here is what? 180 degrees. So we can say sum of angle in triangle in this case is what? 180 degrees. So which means S plus 127 degree here is what? 180 degrees. So getting X here means we are going to subtract 127 degree from 180 degree. And the result that gives is so that finally gives the value of what? Value of 53 degrees. So that is also the complete solution to the fifth question. And the next is question 6. So in my number 6, I have something like this. N here, N here, P, center O. And this is 20 degrees. Now, we have to find the value of P, Q, P, N, and what? And F. So the first thing to solving this thing is to think of which of the three theorems is going to be efficient. So we can see that the one which describes the relation between angle at the center as well as angle at the circumference won't be useful here, or because no angle is formed or no angle is given at all at the center. So this is the center. We don't have any angle there. Now the next theorem, which we know, is the one which talks about what? Angle in a semicircle. So now, in order to use that, we have to identify the diameter. So we can see this line is our diameter because it is drawn to pass through the center here. So let us assume this diameter has two endpoints A as well as endpoint B. Then the next thing is we want to redraw. We want to move from this point in such a way that the two movements will come together somewhere else on the circumference of the circle. So that one can be done in two ways. So the movement can be done this way. It can as well be done this way because of the nature of the diagram which we have. So it means when we move, if you want to consider the upward movement, so it has to be like this, here to here, and from here to here. So we can see that here at the angle here, at this point, let's say point C, we will form a new angle. And that angle is here to here. So such an angle is an angle in the semicircle. And it's going to have the value of what? 90 degrees. So when you compare this to the previous question, so we can see that they are more or less, they look alike in the sense that so both N and M are combined. But remember, in order to report our answer, we want to give the value of N separate from that of what? Of the value of M. Now let us reapply the concept of what angle is semicircle the other way around. So in the other way around, from these 2 points here, the movement is also possible from here to here as well as from here to here. So that also shows that movement from here, the whole of this angle here is what? 90 degrees. But we can see very well that part of this 90 is named to what? 20 degrees. Then it automatically shows that this place will be 70 degrees. That this is the result of removing this 20 from 90. It gives this. That is, combination of these two values is what? Is equal to 90 degrees. So this is all the angle semicircle can enable us to achieve. Now the next one we want to use is to think of what? The properties of angle in the angle in the same segment. So using that, So I can pick my 20 for instance. Now let me find the chord upon which this my 20 is resting. Now we have this 20 degrees. So 20 degrees at point D for instance. This point D here. So this angle 20 here is formed when this line and this line joins together. So which means in order to know its chord, I will have to trace from this line down to this place. I will also have to trace it from this point down to C here. So which shows that what? Angle 20 degrees is on chord BC. Now we are interested in any other angle having BC as its base, or any other angle that is resting on chord BC. And when we move appropriately, so we can see that from B a movement is possible like this, and from C a movement is possible like this. So at this point we form a new angle. So we can see this angle here is sharing the same chord, the same base as that of what? Angle 20. So automatically this angle here, this place here becomes what? 20 degree. Now let's also verify the one of 70 degree which we have here. Now this 70 degree is formed by the coming together of these two lines. So which means for us to know the chord where this 70 degree is resting. So what we are going to do is I will move from here down to C. I can also go from this point down to A here. So we can see that angle 70 degrees resting on chord AC. Now then the next thing is, let's verify which other angle is resting on this chord AC. So we can see from here and from C. So it can be drawn this way and down to this place. So which was this place? Is also sharing the same chord AC as that of what? Angle 70. Which automatically means this place is what? 70 degree. Now, we are here to find the value of P. So getting the value of P now means, okay, we've now even done any of the information which we are asked to do. But so far so good, we've been, okay. Now, the next thing we can do is, let's pick angle P for instance. Angle P is on chord BD. Now, which other angle we have on BD? It is M whose value is yet to be determined. So we can say at this point, there is nothing we can do again. Then from this junction, we can now think of what? Moving outside the application of what? Circle theorems, circle theorem properties. Now what we can now do is, either we make use of what? Properties of triangle or properties of angle between lines. Now let's think of properties of what? Of triangle. Now let us assume this place BCD here to be a triangle. Suppose it is a triangle drawn like this, like this. This place is M, we don't know the value. And this place is M, whose value is not known. It's a value, it's a letter whose value is the letter, assume we don't know its value. This point here is 70 degrees, and this point here is 20 degrees. And one other thing, there is mark like this, which shows that the diagram which we are having here is what? This diagram is an isosceles triangle. And we know that isosceles triangle is a triangle that has two of its sides equal and two of its angles equal. So which means we want to identify those two, the basis of this isosceles triangle. So automatically the base of the isosceles triangle is going to be this place, 20 degrees. So that shows that what? Angle M here is what? 20 degrees. And since M is 20 degrees, and remember we said the other time that combination of everything here is what? 90 degrees. So if ordinary this one is 20, so then it shows this place is what? It's going to be 70 degrees. Now we can now think of what? Getting our P. So to get P, we are going to apply the property of angle in the same segment. Now let's check this point that has angle P. And what we do next is what? Move from here as well as this. So when we move here, we want to check the chord where this angle P is resting. So when we move from this side here, we stop at D. From this side here, we stop at where? At D. Now we are not interested in any other angle on the board here that are sharing the same chord BD with P. So we can see this is BD. It is possible I move this way and as well move this way, so which is M. So it automatically shows that this angle P is sharing the same thing, it's same chord as what? As angle M. So since angle M is 20 degrees, so P is as well what? 20 degrees. And that is also the complete solution to the fifth question. So we have one more question before the end of this section on angle between angles in the circle as well as angle in the same segment. So we have to find these three values. Now, looking at this thing, then we can see we have to find four values: x, w, y, as well as t. Now, doing this involves thinking of what? Those theorems. The first of the theorem we learned so far, so good in this class, is the one which illustrates the relationship between angle at the center as well as angle at the circumference. So when we look at this diagram very well, we can see this is the center of our circle. And this time around at the center, angle is formed at the center. So it shows that theorem is going to be useful for the first time in this class. So which means, so using it, we have different diagrams that describes how to use that properties. So there were three basic diagrams that defines the using of what? Angle at the center is what is the angle at the circumference. Now the first of it is this diagram here, and the last of it, that is the top case, then is this as well as this. Now let's think which of the two properties do we want to go with. I prefer to go with this one below here. Now remember, institution of this kind of diagram, its center is going to be outside, it's going to be an angle outside, it's not going to be within. So therefore, this place called W is going to be the center for this case. Why this 126 degree we have here is going to be its what? Its angle at the circumference. So we can now apply the theorem. So the theorem says that whatever we have at the center is 2 times whatever we have at the circumference, 126 degrees. So there we can see that has a value of what? 252 degrees. So we can say our this thing is 252 degrees. So we are done with this one. Then the next is we want to talk of the first case of diagram that talks about what? Angle at the center is twice the angle at the circumference. In that situation, this place is the center, while this place is going to be the circumference. Now let's draw the relationship between center as well as circumference. When we observe this thing very well, we can see the angle at the center is not given, and angle at the circumference is not given. So once it's like that, we have normally we shouldn't be able to do anything again. But we have means of reasoning. So the way we are going to reason now is to do what? To now find a relationship between angle at this center, angle at the point here. So the relationship between the two now is going to be what? Summation of everything here is going to be what? 360 degrees. There we say that x plus 252 degrees is equal to what? 360 degrees. So the theorem here is what? Sum of angle at a point is 360 degrees. So getting x here means we say that what? X is going to be 360 degrees minus 252 degrees. And x in that case gives the value of 108 degrees. So x in this case is 108. So this is 108 degrees. So once we know the center, it's very possible to find angle at the circumference. So we can now say that what we have at the center here is 2 times the angle which we have at the circumference. So that means to get in my y here, both sides will have to be divided by what? By 2. So when this cancel this, so we can say y in this case is what? 54 degrees. So this place is now 54 degrees. Now the last thing we want to do is to find t. So we can see this t has nothing to do with the application of what? Circle theorem. Now we have to think of what else can we do in order to get this t. So and the position where we have t, in fact we don't have anything triangle on the board. So we don't have anything triangle on the board. Shows its property of angle between lines. That's what? That's going to be of what? Of importance. So using that one simply means we want to consider the line where we have angle t. And remember, sum of any angles we can have on a straight line at all is what? It's going to be 180 degrees. So it shows that on this straight line there are 2 angles. The first angle is the movement from here to here. Second angle is movement from here to here. So summation of all angles which we have on this straight line become is what? 180 by the fact, by the theorem. So it shows that combination of y here and t here is equal to 180 degrees. So reason for this is what? Sum of angles in the triangle is what? 180 degrees. But remember, we've gotten the value of y here to be 54, so that value would have to be substituted, which means 54 degrees plus t here is 180 degrees. Is 180 degrees. So to get in t here means we are going to collect the like terms, and t gives the value of 126 degrees. So the value of t in this case is what? 126 degrees.